Forces resolution. What we mean by resolution of force. Resolution of a force into two given directions. We have the force R is the resultant force, and we want to resolve this force into two components, F1 and F2, such that R inclined with an angle of measure θ1 with F1, and R inclines with an angle of measure θ2 with F2. So the required is to find the F1, the magnitude of F1 and the magnitude of F2 as follow. So figure 1 shows resultant vector R here, which is required to be resolved into two components. Two components, as we said, F1 and F2. The two components are F1 and F2 in the two directions, ray OA and the other ray is OB. Okay, so the two directions are OA, ray OA, and ray OB. So F1, again F1, the component F1 is in the direction of ray OA, and the force or the component F2 in the direction of the ray OB, which make angles of measure θ1 and θ2 respectively with R. So F1 makes an angle of measure θ1 with R, and the other component F2 makes an angle of measure θ2 with R. And you can say that R inclines with an angle of measure θ1 with F1, and the R inclines with an angle of measure θ2 with F2. Figure 2 shows vector AC equals vector OB. From the given parallelogram, we can note that the vector AC equals the vector OB. So in this triangle, we called it triangle of forces. F1 on the direction OA and the F2 in the direction of ray AC, and the R is the resultant, and the required is to factorize it. Applying the sine rule, you can say that F1 over sine θ2 equals F2 over sine θ1 equals R over 180 minus θ1 plus θ2, such that the measure of the angle OAC, equals 180 minus θ1 plus θ2. And we know that sine 180 minus θ1 plus θ2 equals sine θ1 plus θ2. Note that sine 150 equals sine 180 minus 30, and sine 180 minus 30 equals sine 30 equals half. So sine 150 equals half, also sine 30 equals half. Note that 150 is 180 minus 30, like in our example here. Sine 180 minus θ1 plus θ2 equals sine θ1 plus θ2. So the required rule, and we will use it always, F1 over sine θ2 equals F2 over sine θ1 equals R over sine θ1 plus θ2, as we will see in the examples. Resolve a force of magnitude 12 Newton into two components inclined to the force by angles of measure 60 degrees and 45 degrees into two different sides of it. Approximate the result into 4 decimal places. Again, we have a force of magnitude 12 Newton and the required is to resolve this force of magnitude 12 into two directions, 60 degrees and 45 degrees, with the force of magnitude 12, and in two different sides of it. First, we draw a simple figure to show our problem. We have R is the resultant force of magnitude 12, and we wanted to resolve this force R into two different directions, F1 and F2, inclined with the two angles 60 and 45 degrees. So we consider 60 degrees is theta 1 and theta 2 is 45 degrees. Applying the rule, we find that F1 over sine theta 2 equals F2 over sine theta 1 equals R over sine 45 plus 60 as follow. By applying the sine rule, we can get that F1 over sine 45 equals F2 over sine 60 equals 12 over sine 105. 105 is the result of adding 60 plus 45. Cross multiplication, what you find, F1 equals sine 45 multiply 12 over sine 105, approximately equal 8.7846 Newton. And F2 equals sine 60 multiply 12 over sine 105, approximately 10.7589 Newton. Question 1. Resolve a force of magnitude 36 Newton into two components. Inclined to the force by angles of measure 30 and 45 degrees into two opposite sides of the force. So the main force, the resultant force is 36, and we will draw a figure to show our problem. We have here the force of magnitude 36 Newton and F1, F2 in two different sides of the force of magnitude 36, and the theta 1 equals 30, theta 2 equals 45. Now applying sine rule, we can set that F1 over sine theta 2, F1 over sine 45 equals F2 over sine theta 1, and theta 1 equal 30 degrees. So F1 over sine 45 equals F2 over sine 30 equal 36 over sine. The sum of the two angles is 75. And F1 equals F1 equals 36 multiply sine 45 all over sine 75, approximately equal 26.354. And F2 equals, F2 here, cross multiplication equals 36 multiply sine 30 over sine 75, approximately equal 18.635 Newton. Here we have a live application, a lamp of weight 20 newtons. This is the lamp of weight 20 newtons, suspended by two metal rods AC and BC, AC and BC, inclined to the horizontal by two equal angles. The measure of each is 5 degrees. So we can deduce that triangle ABC is an isosceles triangle. The required is to solve to resolve the weight of the lamp into two components in the direction of AC, this direction, and in the other direction BC. So we have W1 and W2, approximating the result to the nearest Newton. And to construct this segment, we have the measure of this angle equals 5 alternate position, and the other angles also equals 5 degrees. The measure of this angle equal these vertically opposite angles, each of them equals 5 degrees. So what is the measure of this angle and this? Both equals 85. We can calculate the measure of each by many ways. So W1 inclines to CO by an angle of measure 85, and W2 inclines to CO by an angle of measure 85 degrees. So we consider this 85 is theta 2 and this 85 degrees theta 1, and applying the sine rule, we can write W1 over sine 85 equals W2 over sine 85 equals 20 over sine 85 plus 85, which equal 170. Then W1 equals W2, which equal to 20 multiply sine 85 over sine 170. Again, W2 equals, from here cross multiplication, W2 equals 20 multiply sine 85 degrees over sine 170. From that we get, of course, we have W1 equals W2. We have W1 equals W2 because they have the same denominator, which is sine 85. So W1 equal W2 equal this number, approximately equals 115 Newton. Notice that the required is to approximate the result to the nearest Newton. So there is no decimal. So it's approximately equals 115 Newton. Resolution of a force into two perpendicular directions. In the previous examples, these two directions of AC and BC, the directions of W1 and W2, they includes an angle of measure 170. But in the next case, the required angle will be 90 degrees. So the two directions are perpendicular. Again, resolution of a force into two perpendicular directions. We have R, and we want to resolve this resultant force into two perpendicular directions, F1 and F2, and the angle between them, between F1 and F2, is 90 degrees. So if this angle equals theta, so the other angle will be 90 minus theta. Again, if theta 1 equals theta, then theta 2 equals 90 minus theta 1, or 90 minus theta. Okay, applying sine rule, we can write F1 over sine theta 2, again F1 over sine theta 2, but theta 2 equals 90 minus theta. So we can write F1 over sine 90 minus theta equals F2 over sine theta equals R over sine theta 1 plus theta 2. And theta 1 plus theta 2 This sum equals 90 degrees. So we write 90 degrees. Again, f1 over sine 90 minus theta equals f2 over sine theta equals r over sine 90, and sine 90 equals 1. So we can write f1 over cosine theta, because sine 90 minus theta equals cosine theta. Sine 90 minus theta equals cosine theta, and sine 90 equal 1. So the sine rule will be in this form: f1 over cosine theta equals f2 over sine theta equals r. Cross multiplication, what we have? We have f1 equals r cosine theta. In the direction of OA, it is very important case. f1 equals r cosine theta, and f2 equals r sine theta. And hence we deduce that f1, magnitude of the component in a given direction with an angle of measure theta, equals r cosine theta. And f2, magnitude of the component in the direction perpendicular to the given direction on the direction of OB, equals r sine theta. So all you have to know, and you have to consider, that f1 equals r cosine theta, such that theta is the included angle between r and f1, and f2 equals r sine theta, and theta is the value or the measure of the angle included between f1 and r. So we will use the measure of this angle theta twice. Example: resolve a force of magnitude 18 Newton into two perpendicular components, where one of them inclines to the force by an angle of measure 60. Solution: we have the main force, the resultant force is 18 Newton, inclined to F1 with an angle of measure 60. So F1 equals 18 cosine 60, and F2 equals 18 sine 60. And back to our rules: F1 equals 18 cosine 60, and cosine 60 equals half. So we have F1 equals 9 newtons, and F2 equals 18 sine 60, and sine 60 equals root 3 over 2. So the result will be 9 root 3 Newton. Question: resolve a force of magnitude 6 root 2 Newton that acts in the northeast direction into two components. One of them acts in the eastern direction, the other in the northern direction. Solution: first of all, we draw a graph to represent this problem. We have the force 6 root 2 acts in the northeast here. It means this force bisects the angle between vertical and horizontal. So it's inclined to F1, inclined to east by an angle of measure 45. So we have F1 and F2. Now it will be very easy. F1 equals 6 root 2 cosine 45, and F2 equals 6 root 2 sine 45, the same angle. And we calculate it. So F1 equals 6 Newton, and F2 equals 6 Newton too. Now we have a very important case. It is the inclined plane. A body of weight 6 Newton is placed on a smooth plane inclined to the horizontal by an angle of measure 30. Find the components of the weight in the direction of the line of the greatest slope and the direction normal to it. The direction perpendicular to it, it is the same meaning. The direction normal to it, it is the same meaning of perpendicular. Solution. First, we draw a figure to simplify this problem. To represent this problem, we have 6, the weight 6, on inclined plane. This inclined plane inclined to the horizontal with an angle of measure 30. Again, we have a weight 6 Newton placed on this inclined plane, which inclined to the horizontal with an angle of measure 30. And the required is to resolve this force, the force of weight, into two perpendicular directions. One of them, it is F1 in the direction of greatest slope of the plane, and the other is F2 perpendicular to it. So the angle between the direction of F1 and the direction of F2 equals 90 degrees. Now, the measure of this angle is 30. What is the measure of this angle between vertical and horizontal? It is 90. So the measure of this angle is 60, because 60 plus 30 plus 90 equals 180. And the measure of the angle between the direction of F1 and F2 equals 90. Now 60 minus 90 equals 30 degrees. So the measure of the angle between F2 and the weight 6 equals 30 degrees. Now we can resolve this force. We will find that F2 equals 6 cosine 30 and F1 equals F sine 30 as follows. F1 equals 6 sine 30 and F2, which equals 3 Newton, and F2 equals 6 cosine 30. 6 cosine theta and theta equal 30. And we calculate it, equals 6 cosine 30, which equals 3 root 3, and you can use your calculator to make sure that we have the right answers. 3 root 3 and 3. Question 4. An inclined plane of length 130 centimeters and the height 50 centimeters, a rigid body of weight 390 gram weight is placed on it. Find the two components of the weight in the direction of the line of the greatest slope of the plane and the direction normal to it. Solution. First, we draw a figure to represent the question. We have a horizontal and the inclined plane of length 130 centimeters, and the height of this plane equals 50 centimeters, and this plane inclined to the horizontal with an angle of measure theta. We don't know the measure of this angle, the inclination measure. We consider this triangle is ABC, and first we calculate the length of AB. So using or applying Pythagoras theorem, we get AC power 2 equals, AB power 2 equals AC power 2 minus BC power 2 equals AC power 2 minus BC power 2 equals 130 square minus 50 squared. After you calculate it, you will get AB equals 120 centimeters. AB equals 120 centimeters. And we have this weight of magnitude 390 placed on this plane. 390, and we wanted to factorize it into two perpendicular directions. One of these two directions perpendicular to the plane, and the other in the direction of greatest slope. This component equals 390 cosine theta, as the included angle between the perpendicular component and the weight is theta. We have theta here. The measure of this angle equals theta. And in the other direction, we have a component of magnitude 390 sine theta. And now it's easy to calculate it. F1 equals 390 sine theta, and sine theta equals opposite over hypotenuse. Sine theta equal opposite over hypotenuse. What is the length of the opposite? What is the length of CB? It's 50 over the hypotenuse. So 50 over 130. So after simplify, we get F1 equals 150 gram weight. F2 equals 390 cosine theta, and the cosine theta equals 120 over 130. Adjacent, the length of adjacent in triangle ABC over the length of hypotenuse, which equal 130. The length of AB is, again, F2 equals 390 cosine theta equals 390 multiply 120 over 130, because cosine theta equals the length of the adjacent, the length of AB, which equal 120 centimeters, over the length of hypotenuse AC, which equal 130 centimeters, and the result F2 equals 360.